Well, 12 is the same thing as, I think. Okay, well, yeah, there are some extra questions. So let's look at the extra questions that can occur. This is how you graph the things, right? And I do ask you to show the full details of the calculation. Review the early videos, okay? We can come back and talk about that if we end up having time. I don't want to keep moving. What about the domain of each function? Okay? On the table, the domain is a set -2, -1, -1/2, 0, 1/2, 1, 2. And if you graph the function on that domain, you only get these points. And the range is what? Well, the domain consists of these values on the x-axis, and the range consists of the numbers on the y-axis that correspond to your points. So the range is a set 0, 1/4, 4. And 1, okay? I guess I'm going to correct that. Okay. We don't list 4 twice. This is a set. It's already in the set. We don't have to put it in the set again. Doesn't matter how many times it occurs, we only list it once. Okay? So I'd probably fuss if you listed it twice. Might not penalize it. If I'd penalize it, then maybe at most 1 point out of 10. But when you write a set, you don't repeat stuff. The whole thing of a set is it in there or isn't it? Okay, well, 4 is clearly in there no matter how many times you list it. So you're not going to list it more than once. It complicates the picture. Okay, well, that's for this function. For this function, I'll do a little abbreviating. The domain is, again, the set of x values that appear. Okay? And 0 doesn't appear because 0 is not in the domain. You can't evaluate 1 over x for x equals 0. And of course, you did the homework. You know, if you had like 1 over x plus 5, you can't have x equals 5 because you don't have division by 0. If you got the square root of x plus 7, then x has to be at least -7. Because if x is less than -7, you have a square root of a negative. You need to know those things about domain. Those things can appear. Okay. So anyhow, the domain is the set of all these numbers except for 0. You can't have 0. Range is the set. Well, here are your y values. Okay. Now I'll list them in order. -2, -1, 1/2, not in the order they appear in the table, because usually you want to see a set of numbers in order from least to greatest. It's just a natural way to look at them. It's not not the order in which they appear when you do the table. But there's your range. Okay, your basic exponential function. We don't include -1/2 or 1/2 because you can't write it out exactly. It's an infinitely long, never repeating decimal, okay? You can't write the whole thing out. And you certainly can't calculate the whole thing, with or without a calculator, okay? And the criterion we use for domains is you have to be able to calculate it by hand, okay? Now there's a method for calculating the exponential function by hand. You use an infinite series, okay? It includes things like 1/x and 1/x², and a multiple of each of these things. Or a multiple of x and a multiple of x², and so forth. You don't want to get there, okay? That's a topic in second semester of an engineering calculus course. So, we don't include 1/2. Now, if you want to include 1/2, if you explain how to use the Taylor series to do it, that's fine. But you'd have to learn a lot of calculus to do that, and you're not going to do that. So, I don't want to see 1/2 in that domain, right? I want to keep this to numbers that you know how to calculate. For two reasons. One is, most people don't know how to calculate a lot of these numbers, even though it's 5th grade mathematics, because calculators have been way overused. And it doesn't give you an immediate understanding of the function if you don't know how to calculate it and don't know the meaning of the numbers. So for the whole semester and for the rest of your life, probably, you're dealing with things you don't fully understand. I want you to fully understand these functions, at least on these domains. Okay, so there's your domain range. These numbers. Again, you have to use the laws of exponents to calculate this, especially things like negative exponents. Okay, well, I'm not going to list the domains and ranges in these. This gives you the idea, and we do want to move on. I mean, if you really, really, really want me to say so, then just kind of, okay, give me a gesture, since you're not allowed to talk with things on. Yeah, you're allowed, you just, no penalty, it's just that we have to trash the video and you don't have it then. Okay. Yeah, I guess that is a penalty. It's not a punishment, it's just what happens. So we have those questions on number 11. On number 12, there are some more questions. I didn't want to put every possible question on any problem. It gets too long. Except on number 12, it looks like I did go a little further. And I would probably eliminate most of these questions and go to the extended graph. Now, the extended graph is this curve, a smooth curve that fits these points. Okay? So, I'll say the curve is what I call the extended graph. And the reason I make these distinctions is just so we can talk intelligently about domain and range based on these functions. There are two versions of the function. One is just the points that you get from the table. The other is the curve you get dictated by the points. okay? So, the domain of a curve is the interval from -2 to 2. Okay? The range is the interval from 0 to 4. Now you'll understand that if you did and understood the assignment, okay? Because that's exactly what the assignment would tell you. And of course, what I did in class last time is I said, well, here are the x values. They go from here to here. So your domain goes from -2 to 2. And your assignment told you about interval notation, but that's a fairly simple notation, okay? So, you know, take a look at what math tells you if you're not sure about that. And your range is your set of y values. So just to, you know, make it as clear as possible, you're going to make the extended function blue. The extended function stops here and here. And I guess I could put a closed blue dot here to do it lightly so I don't obscure the red dot from the basic function, right? Okay? Okay. That's this function. For this function, well, your extended function again, and I'll go ahead and write this. Okay, there's your basic function. And here are your x values, your domain, and here are the y values that constitute your range. Once you've drawn the curve, your x values go from -2 up to 0, but they don't include 0, so we put an open dot there. We have a closed dot here. And then they pick up, that's wrong. Because for the extended basic function, we stop here. We don't even go past -1/2. Apologies there. Okay. So the domain starts at -2 and goes up to -1/2. Make sure we got a red dot in the middle. And then it picks up again at 1/2 and goes to 2. Does that make sense? So, yeah, goes up to here and stops. Picks up here and goes on. Now, the complete basic function, which we don't talk about in this course, because I want you to understand this much before you see that, but it's fairly simple. If we keep going closer and closer to 0, 1 over x gets bigger and bigger, maybe in the positive direction, maybe in the negative direction. So the domain goes all the way up to 0, and the range goes all the way up to plus infinity here, approaches plus infinity, and approaches negative infinity here. Again, don't worry about that in this course, but you're going to have to worry about it very early in a pre-calculus course. Okay. So there we have some of the picture. Let me draw the rest of it. Okay. I'll trace this over in blue. Put a big dot, closed dot here, light closed dot, closed dot, here and here. Yeah, I'm gonna make that about a little darker, and I'll just put a rest out there. Okay. And now we can see the range, which goes from here to here, and it's closed. And the range goes from here to here, and it's closed. So the domain of the extended is what? It's the interval from -2 to -1/2 union with the interval from 1/2 to 2. That's a notation you saw in the homework, okay? And if you haven't done the homework, do it. It's not hard. I would have checked your homework, except not getting any internet in here, okay? And the range of the extended function is, well, it's actually the same as the domain. Here's the interval from -2 to -1/2, and here's the interval from 1/2 to 2. Okay. Here, I'll just list the domain of the extended function is -2 to 2. When you do the table, you see that the smooth curve extends from x equals -2 to 2, and from y equals 1/4 to 4. There's a little confusion because we don't use -1/2 or 1/2 in the domain of the basic function. But 1/2 is included in the domain of the extended basic function, because clearly when you draw this curve, there's no reason not to include the point where x equals 1/2, right? X equals 1/2 here. There's a perfectly good point on that curve. 1/2 is here, -1/2 is here. Okay, you don't know what the value is. It's approximate. Approximately 1.4 at 1/2, approximately 0.7 at -1/2. You could estimate that from the graph. You could get that from your calculator, but it's not exact, so we don't include it in this domain. But certainly be included in this domain, as are all the other points. Okay? Okay, well then you do analogous things with these two. So that's what we're talking about there. Now, I'm not sure we actually did that. But I gave you instructions here to, the instruction on number 12 says, extend your graph by sketching a smooth curve dictated by the points you've graphed. Well, that's pretty clear, right? If you got these points and you're required to know how to do those points, then you can sketch the curve. And then you can see what the domain is for your sketch curve. Okay? I'm not sure how much we did with that early. I'm going to include that on the test. I might not penalize it real heavily if you don't get it, but it's a really good thing to understand because it reinforces your understanding of domain and range, which you get like in the first week of pre-calculus, okay? Or at least within the first 2 weeks. Again, you want a head start in pre-calculus. That gives you a fairly good one. Okay, let's see. Now there's one more problem I think that we haven't talked about. Actually, a couple. That's 12 and 13. Then we got 4 and 5 and 17 on the second test. Second version. Then we'll see what questions you want to clear up and see if there are others that you want to look at. Get those numbers again. Number 5. I don't guess we talked. Did we talk about number 5 or 6? Is that version 1 or version 2? Version 1. No, that's version 2. Okay, well, one question's easy to answer. So, let's just all this off so I can use as much of the board as possible. You have the fraction that's written 2 over 3 times 1 over negative 2. Okay, well, that means, of course, 2/3 times 1 over negative 2, right? If by order of operations, 2 divided by 3 means 2/3, 1 divided by negative 2 means 1 over negative 2. Your rule for multiplying fractions is you multiply the numerators that's 2 over negative 6, right? No. Two times 1 is 2. 3 times negative 2 is negative 6. Okay. We'll come back to that because we've got to be done here in a minute. So hold that objection. We'll see if there's a problem with it. Because every time you raise that objection, there's something wrong. I haven't seen you be wrong about it yet, but and then we can write this as negative 1/3. That's just basically that's a fraction. Oh, wait a minute, I see what it is. That's not the question. Okay, it's divided by, right? Okay, so, well, that's how you do it if it's multiplied, right? Now, I didn't see this flash. Divided by 1 over negative 2. Okay, well, that's, okay, that's good to see the contrast. Well, that's 2/3 divided by 1 over negative 2, which is 2/3 multiplied by negative 2 over 1. Okay. You divide fractions, you multiply by the recipient. And the same goes with rational expressions. And that equals then negative 4 over 3. And that doesn't simplify. Am I right this time? Oh, good. I'm relieved. Okay. Very good. Now let's see, of course, number 17 of the second tab. Okay, yeah, this is a good one. Height of ball is y equals negative 16t squared plus 52t plus 4. Okay? We want to know what the maximum height is. Okay, to solve this, first of all, you got to recognize that this is a quadratic function. Okay? So we can graph it. It has a highest or lowest point. Every quadratic function has a highest or lowest point because it's a parabolic graph, meaning it's either like this or it's like this, upside down. Either right side up or upside down if you wish. It's like this. Okay? Matter of fact, any quadratic function, you can take this and move it. and maybe invert it, and then maybe spread it out this way or spread it out this way. And you get this thing, okay? And we didn't get into all that, but you're going to see that fairly early in your pre-calculus course. And if you understand this, you're going to be well prepared for it, okay? So, we want to get the highest or lowest point. We really don't care about the zeros. We don't care where the height is zero, but another question might ask where the height is zero. I don't think this one asks. No, it says find the height when the time is 28 feet, right? No, it says find the time when the height is 28 feet. I'll get it right eventually. Okay, highest or lowest point is what? It's the vertex. Okay? Vertex is that x equals negative b over 2a equals negative 52 over 2 times 16. And it's not x, it's t in this case. Okay, the quadratic formula works for t as well as it does for x. Negative 52 over 2 times 16 is negative 52 over 32, which reduces down to 13/8. Okay? The y-coordinate you get by just plugging the x-coordinate in here. Now, in terms of the graph, draw the graph over here, so I probably have room. Okay, in terms of the graph, we have x equals 1, or t equals 1, t equals 2. 13/8 is a little more than 1.5, it's 1.625, but here's x equals 13/8. It's your axis of symmetry, and we've been over that quite a bit in the last week. So hopefully you understand it, or at least if you don't completely understand it, you're motivated to understand it. You're probably going to have a problem with this nature on the test. So there's your axis of symmetry. And then you want to get your y-coordinate. Well, you know what the x-coordinate is. It's got to be on the axis of symmetry, so x has to be 13/8. Or t has to be 13/8. We've been talking about x a whole lot. I learned slowly. Okay, so bear with me. Okay, so we're plugging 13/8 in for t. Now you're probably going to make me calculate this. It's about negative 40. This is half of 13 squared, which is 84.5, so it's 40.5. 84.5, 4.5. So this is about, I've got a ballpark 8.5. I could be way off, but as we're going to say, okay? The y-intercept, we don't have to have the y-intercept to graph this thing, so I didn't ask you to graph it, but I might ask you to graph it. I might ask you to graph a function of this nature. The y-intercept is at y equals 4, because it occurs when x equals 0, and that's something that should be second nature to you. So if t is 0, you're going to get 4. So down here you've got 4, up here, well, let's just put a scale on this. Okay, so I'm gonna say 8 is here. So 8.5, well, if 8 is here, 4 is here. 2 is here, 1 is here, you got 3, you got 6, you got 5, you got 7, you got 9. And 8.5 is about here. So first of all, you've got this point, which is about 13/8, 8.5, or whatever you do. You can use your calculator to do that. You do it by hand. And you got y-intercept at y equals 4, so you got the point 0.04. Now we have a pretty good picture of what the parabola looks like. If you can get the shape of the parabola right, it's going to look something like this. Okay? And then there's this ridiculous question of when is the height 28 feet? And it isn't, okay? It never is 28 feet, so I'm gonna have to edit that. Find the height when t equals 2.1 seconds. Y equals -16 times 2.1 squared plus 52 times 2.1 plus 4. I can estimate this from the graph. 2.1 is about here. So I'm estimating that this comes out a little over 7. And of course, we learned early to make estimates, right? Because they help you check your results. Okay, well, 2.1 squared is 4.41, that's about -64, and then about -71. That's 104, about 110. So that gives us 39 and 4. Something's terribly wrong. Probably wrong with my calculation here. Because when I plug in 2, I get like -64 plus 104, which is 60, plus 4, which is 68. So what kind of bonehead thing did I do here? We're short on time, I don't have time to do it, but I made a bonehead error here. Okay? It's much higher than 8.5. And this comes out something like 40-something. Question mark there, because apparently I can't trust my